and I want to thank everyone for taking a moment. Today our presentation is going to be about Make Your Ideas Matter with 3D Systems MultiJet Printing Technology, which is commonly referred to as MJP. This is going to be about a 20 to 30 minute session with the intro to MJP, and just so you know, we try to have these webinars on 3D printing or 3D scanning on a quarterly basis, so stay tuned for the next upcoming event on that. Just to kind of do a very quick overview of D3 Technologies, for those of you that don't know anything about us, we were founded in 1998. D3 is really an engineering design technology consulting firm, and we've got offices located across the central part of the United States, but we really focus primarily on manufacturing solutions to help increase efficiencies, and we do that through technology such as 3D printing, such as some of our data management, automation tools, 3D scanning, our CAM solutions, and of course we are authorized representatives for both 3D Systems and Autodesk as well. So for those of you that aren't aware, 3D Systems is actually the inventor of 3D printing. They're the leader in 3D printing technologies today with about 7 various types of technologies. If you take a look there, you can see when some of the technologies started. It started out with SLA, which they invented back in 1988, and of course that's evolved into other types of technologies. Obviously we're pleased to work with 3D Systems today because they are the innovator and they continue to pioneer for all of us down the road with other 3D printing technologies. I wanted to bring this up because this is something that PwC, PricewaterhouseCoopers, formulated, put together, and they actually published this in the latest Forbes magazine, and it happens to be the 7 ways 3D printing makes manufacturers more competitive. So I just wanted to put up a couple of statistics because this could apply to some of you out there today. Something I found kind of interesting is that 71% of the manufacturers are using 3D printing for prototype and final products, meaning end-use products. That is phenomenal, and we want to continue to grow that because, again, it really does help with the whole manufacturing process. The other thing I thought was also interesting is that 64% of the manufacturers expect to rely on 3D printing for producing older or obsolete products over the next 3 to 5 years. Again, 56% of the manufacturers who are 3D printing early adopters predict that more than half of their peers in the U.S. will adopt 3D printing in the next 3 to 5 years. So I think this is really telling us is that there's really going to be a lot of changes in the next 3 to 5 years. So we're anxious to see some of that, as I'm sure you are too. So let's talk a little bit about multi-jet printing today. First of all, multi-jet printing is really affordable and it's great for prototyping. It's designed for very simplistic things. It's designed across all types of disciplines and work groups, and it's really designed for the office environment. But what you're going to get out of multi-jet printing today is high resolution and accuracy, and that's what's important in the multi-jet printing line. You're also going to find speed and precision with this. Multi-jet printing, we've actually made the speed print time almost double in some of our 3D printers today, and I'll talk about that a little bit. But the whole point is that, you know, multi-jet printing allows you to take those ideas into reality. So you can really go from a design concept to a real part in your hand in just a few hours out there with the combination of high fidelity prints, all the material properties that are available, the fact that it really is easy to use, and more importantly, you can put this in your office today. Here's just an example of the throughput that you're getting with some of our MultiJet printers today. This is an example of parts that were printed in what we call UHD mode. UHD mode is actually, in this case, it's going to be about 16 microns. I'm sorry, excuse me, 28 microns. And this was printed, all of these parts on the build platform were printed in 7 hours and 13 minutes. That's huge compared to our competition out there. Those same parts on our competition was going to take about 17 hours and 50 minutes. So speed within 3D systems, MultiJet printing has really increased far and above and is continuing to do that. That's what you're going to see with 3D printing. Not only more materials, but the fact that it's going to be faster, and that's what this printed allows you to do is utilize. Also within this, you can stack and nest parts. This does not show that we've done that on this particular one, but we can actually do that into a single build. As I talked about, with MultiJet printing, there's a broad range of materials. You've got everything from VisiJet, what we call VisiJet M3 Black, and that's more of a polypropylene-like performance with high flexibility, high strength for snap fit applications. We've also got what we call an ABS-like performance that provides a high stiff plastic. Also, it has high temperature for some rigorous applications. We've also got what we call the crystal material. That's a polycarb-like, and it's translucent material. So you get high clarity for some see-through applications if you're trying to do testing. In addition to that, that material is also Class 6 certified for medical applications. Then of course we've also got a navy and a tech plast. Those are just kind of general purpose with blue and ray colors. And then our last one that also is located here is our castable plastic. And that allows you to do castable plastic or fine features for maybe some foundry applications out there. In addition, with the MultiJet printing, we've also got elastomeric materials. So with our elastomeric materials, you've really got high flexibility, translucent-like finish with our natural material. With this material, you can do, in one of our printers, you can actually do a Shore value of 28 to 32, and it's got an elongation of about 160 to 230%. We've also got our black elastomeric material for one of our printers, the 2500 specifically, and that is a black flexible, again, with the same Shore and elongation properties. In addition, on some of our 2500 models, you can get a rigid black material. You can also get a clear material, which is great for translucent. Again, you'll see the tensile strength there, which is about 40 to 50 MPa, an elongation of 9 to 18%. We've also got a rigid white that's available. That's a great surface finish, again with the tensile strength of 37 to 47 MPa. The beauty of our MJP technology is that you can print parts that reflect your full design intent because of the fact that with the MultiJet printing, you actually have overmold application or designs. You can do that with our MultiJet printers. So you can print medical applications possibly, or organs if you need to for clear material visualization. Or you can apply markings or letterings on some of these. So it really does allow you to do a lot of various things. The beauty of MultiJet printing is that it really does allow you to lower your cost for printing out prototype parts. It saves you cost of material and of time by reducing material changeover. So for instance, if I want to flip from a black to a white, or if I want to go from a rubber to a rigid material, I don't have to exchange I don't have to do a material changeover process. I simply pull out the cartridge, it's a 2-kilogram cartridge, and input the other cartridge of that particular material. So it really does save you a lot of time and allows you to run all these various materials and allows you to produce over-molded parts. So I could run everything from an ABS all the way to a rubber-like material all in one particular part and be able to test my prototype. This is a really good example of the elastic material that you get in these printers with a 656% elongation, and I just want to show you a video with this because it shows So I hope you got a good idea there. I wanted you to see the elasticity that you get in our rubber-like material and notice that it really goes back into shape, original shape that it started out with. So it's really got very good material properties for that. As I talked about, the beauty of, for instance, the 5500 is it really allows you to mix those materials on the fly. So you can choose virtually any number of combinations to get the properties that you want. Color is controlled directly by the ratio of your materials that are used, and your shore hardness is actually controlled in two ways. It's controlled by the ratio of flexible and rigid material used. It's also controlled, the shore hardness is controlled by jetting patterns. Every pixel of a part is jetted and it's a controlled pattern that affects its overall performance. So once you define, for instance, the outer shell material, that might be different from an inner core material, so you can achieve a lighter color with a more flexible or vice versa. The color and hardness variables really are not completely independent. For example, you can have a completely flexible white part or a completely black rigid part. So again, it just allows you to have different material choices when you're actually producing a part in the MultiJet printer material. Obviously, we all know that time to market is becoming ever so critical in the success of manufacturing today. So again, that's what MultiJet printing allows you to do with all of these various materials, whether it be clear, ABS, or rubber-like. Again, ABS, polypropylene, polycarb-like plastics, flexible elastomers, black, white, clear, gray, and more. Again, materials that allow you to do this capability. This is just an example of a success story that I thought might be interesting. This is Citizen Watch Company, and they actually use our MultiJet printer technology in their design and manufacturing process. To maintain their confidential development strategy, Citizen relied on prototyping, their in-house prototyping division. But before they actually got a 3D printer, they used CNC mills to create mock-ups of a final watch design and assembly jigs. And then they decided to bring in 3D printing to speed up that process. So here's how they use MultiJet printing. First of all, they take advantage of the MultiJet printing to print very fine detailed features in watch designs. They also take advantage of MJP so that you can paint them or dye them to get a very good or accurate representation of their potential new products. And then they go beyond that with MultiJet printing to manufacture a common jig for assembling multiple watch models. So now they 3D print customized jig for every model, giving them optimal shape for the required fit. So really what they did with MultiJet printing in-house, they took a 20 to 30-day process into an overnight production. So what can you use MultiJet printing for? Look at all these areas you can use it for. Functional prototypes, whether it's assembly, form fit testing, or maybe aerodynamic testing because the materials are airtight, watertight. You can do fluid flow analysis as well. For concept models, if you want to do just quick, rapid design iterations, if you're trying to communicate something either internally or with your customer, it's a great solution. But you can also use it for rapid tooling. If you want to do short-run injection molds, or if you want to do hydroforming, thermoforming, or maybe even sacrificial casting patterns, there's so many applications that can be used with MultiJet printing. And here's just an example of who actually acquire the types of industries that are using MultiJet printing 3D printers from 3D Systems today. People like automotive, aerospace, consumer electronics, medical, education, just a whole host of whether or not they're trying to do concept parts all the way to end-use parts or possibly even tooling. I just want to show this video real quick so you get a good example of how MultiJet printing works, just to give you the very basics here. So hopefully that gave you a good idea as to how it works. Basically, it jets out multiple jets of acrylate plastic, and then just as they're about to solidify on the build plate, it actually uses a UV ray to cure it. And keeping in mind that it uses wax for the support material, it doesn't actually use the material, it uses a paraffin wax. And then that paraffin wax is simply removed, which I'm going to talk about here in a moment, with a very easy process. And I don't want to go into all the speeds and feeds on this because I really want you guys to just have a good understanding of where and how MultiJet printing is used and why. But I am going to show you the 3 different models right now that are available with this, and it kind of shows you the build envelope of 11 by 8 by 5.6, and that's on the ProJet MultiJet printer 2500. We've also got the ProJet 3600. It's a little bit bigger build chamber, but it also has various materials and various resolution layers, as you can tell, from 32 microns down to 16 microns. And then the last one is our, I call it the Big Mama. It's primarily a large build chamber, 20.4 by 15 by 11.8. And with this unit, clearly you can do various types of materials, everywhere from elastomeric all the way down to ABS, all in one printed part. So those are the 3 different models that are available in the MultiJet printing. Certainly I'm happy to go into more details with you guys later, but I just wanted to give you a quick overview on that. By the way, notice on this you can go from 25 microns all the way down to 13 microns resolution. So something that I just want to talk about is now continuing on with how it works. Each of these units come with a software. You're going to take it from your CAD. You're going to export out as an STL file. It's going to come into this software called 3ds Sprint. That's the client software, and that's where you're going to determine basically how the printer is going to print it, meaning it's going to place it on the build chamber, so you can do a printability check. You can even do some file repair with this. It automatically sets the part positioning. Of course, you can override that. It's going to tell you how long it's going to take to print and how much material it's going to take to print. So it lets you know ahead of time if you've got enough material in there. And you also do print queue management with this. By the way, with this software, if you have a smart device like an iPhone or an iPad, you easily can access it from home or off-site, so you don't have to be there to know when that part's going to be done or about how it's doing at this point in time. So this software comes with every 3D printer that we put out there as the go-between, and then you simply hit print from the software and it starts printing into your printer. So what makes MultiJet printing better and gives you more geometric freedom? Since in this case with MultiJet printing, it's paraffin wax that really holds your parts together as they're being printed. So as long as there's a way for the wax to escape from every cavity, it's almost limitless complexity. You don't need to worry about mechanically removing supports at all because of the process that we go through for removing that wax removal. So you can think outside the box. That's the beauty of this. It really does allow you to get much better parts as a result because we're using paraffin wax for the support material. In addition, you're able to get those high fidelity parts. You're able to get those small features. It's really true to your CAD. And like I talked about, it's easy post-processing, which I'm going to get into here in just a moment, because of the fact that it's easy to remove those wax supports. This is the example of the higher fidelity part. Take a look on the left. That is an example of a part that we printed off of our MultiJet printer. If you take a look on the right, you can see my competitor, that same part. Huge difference between the two print technologies. Ours is clear. Every circle is completely round. Every square is completely squared off. So really this, and by the way, this is an example of a shower head nozzle, so you can see how it's got to be, fine, high fidelity parts. So what makes our MultiJet printer better? It's called phase change chemistry. It's because it has a high X and Y resolution and the thin Z layers from just 13 to 32 microns. So that's part of it, and that's why it excels in such great detail. But as it turns out, it's even more than just the raw resolution. It's the chemistry and the process of the way that the printer employs it. So 3D Systems uses the MJP thermally controlled materials for superior print definition. As each heated droplet of material is jetted, it immediately cools and it holds its shape just as it lands on the part or the support paraffin wax support surface. So the printed material does not ooze out all over the edges like our competitor does there on the right. So your edges, or even pool in the corners, so the edges are sharp, the holes are round, as I talked about, the features are going to be, and the sidewall quality is going to be perfect. That's why ours is different from the competitors. Again, take a look at this example where we've got finer details. You can really see it here. You can see that the top of the features, if they even survive with the competitors, but in this case you can really see the clear detail. So what makes MultiJet printer again is the easy post-processing. And this is kind of a sped up video, but it's hands-free. So when I pull all those parts off of that build plate, I'm going to put them into two options. Either you can use a convection oven and that melts it off, or you can even use a steam bath where it steams off all the paraffin wax and melts it away. So there's no, you can batch them all together, put all your parts in one. You don't do by hand removal, so there's no risk of damaging the part. If you've got intricate details, it's fast. You can do it within 15 to 30 minutes depending on how many parts, depending on how the geometry is. There's no special plumbing that's required. There's no caustic chemicals. That's the beauty of our technology. This is just one example. As I mentioned, there's also, you can use a commercial and convection oven. This is another one. This is an easy clean system. It's really, I call it, it kind of looks like the buffet style food delivery, but it's a steam-based wax removal. There's two warmer units, one for the bulk wax that removes it, and then you've got one for the fine wax removal if you've got really fine parts. It's really even faster than the traditional convection oven, and it's easy setup as well. So hopefully you guys have gotten a good idea as to what all you can do with MultiJet printing today. Certainly, if there's any questions, please jot down my email address or jot down my phone number. I am more than happy to talk to you in detail about it, find out if your applications make sense for MultiJet printing or not. Again, thank you so much, and I appreciate your time, and have a very good day.